Hi guys, this is Mrs. Ulry, and I'm going to talk to you, or actually help you work through 4 example problems dealing with redox titration. So in this first one, it's telling me that I have a sample of ore that contains iron. The mass of that sample is 4.23 grams, and we're going to dissolve it in hydrochloric acid and then reduce it so that all of the iron ore forms 2+ ions. Then we're going to take those Fe2+ ions and we're going to completely oxidize it by adding 31.6 milliliters of a 0.0512 molar solution of potassium permanganate. Those things react, so iron and potassium permanganate react according to the balanced equation below. What this is asking for is for us to determine the mass of the iron in the sample and then what is its percent. So in order to do this, we need to know how many moles of iron were in the sample. And to do that, we have to figure out how many moles of potassium permanganate we had to use, specifically how many moles of permanganate were used. So to do that, we're going to take our volume of our manganate ions, which was 31 milliliters, which is going to equal 0.031 liters. And then we want to cancel liters and we want to get to moles, so we're going to use molarity to do that. So remember, molarity is moles over liters, so what this really means is for every 1 liter of permanganate ions, we have 0.0512 moles of permanganate. So that gives us a total of 0.00161792 moles of permanganate ions. So now that I know how many moles of permanganate ions, I need to know how many moles of iron would go with that. So I'm going to make a mole ratio based on the balanced equation above. So I know that for every 1 mole of permanganate ions, I require 5 moles of iron ions. So using that mole ratio, I know that I have 0.008086 moles of iron ions in that sample. So now it's asking me, what is the mass? So what is the mass? I'm going to take my moles of iron and convert them to grams. So I'm going to take my moles of iron and then I'm just going to multiply by the molar mass for iron, which is 55.845 grams, is equal to 1 mole of iron. So that tells me that I have a total of 0.4518 grams of iron in my sample. So what is that percent by mass? So now all I'm going to do is just a regular percentage. I'm going to take the mass of the iron divided by the total mass of the sample, which was 4.230 grams. I got that from right here in the problem above. Multiply that by 100, and that means that that sample, this 4 gram sample of ore, was about 10%, 10.68% iron. All right, that's example 1. Example 2, it says I have 100 milliliters of a 0.5 molar solution of magnesium bromide, and it's used to reduce 50 milliliters of a solution of acidic potassium permanganate. Calculate the concentration of the permanganate ions in the solution. Then we have the balanced equation below. So what I'm going to do is I need to figure out how many moles of bromine ions I have. So I'm going to take my volume of bromine ions, which is 100 milliliters, which is the same thing as 0.01 liters of bromine. And then I'm going to multiply it by its molarity. So I know that 1 liter of bromine has 0.5 moles of bromine ions in it, according to this up here. So that means that I have 0.005 moles of bromine. So now I need to know how many permanganate ions go with that. So I'm going to set up a mole ratio. So I know that for every 10 moles of bromine, I require 2 moles of permanganate to go with that. So 0.005 times 2 divided by 10 is 0.001 moles of permanganate. So now that I know how many moles of permanganate that I have, what I want to do is figure out my molarity. So remember that molarity is going to be moles over liters. So I know I have 0.001 moles of permanganate, and then in my problem above, it tells me that I have 50 milliliters of solution, which is going to be the same thing as 0.050 liters. So 0.001 divided by 0.050 gives me 0.020 molar solution. Okay, on to example number 3. So it says what volume of 0.05 molar potassium permanganate is needed to oxidize all the bromine ions in a 25 milliliter sample of 0.2 molar bromine. So what I'm going to do is I'm going to start with my volume of bromine. I'm going to multiply it by its molarity. So in 1 liter of bromine, I have 0.2 moles of bromine ions. That's going to give me 0.005 moles of bromine. I'm going to take my moles of bromine and I'm going to see how many moles of permanganate would go with that. And I know that for every 10 moles of bromine, I have 2 moles of permanganate. This looks pretty similar to our previous problem. So I know that that is going to be equal to 0.001 moles of permanganate. So the last thing that I need to do is figure out volume. So I know I have this many moles, and I know that my concentration of permanganate was 0.05, so I'm going to take my number of moles and I'm going to multiply it by the fact that I know that there are 0.0500 moles of permanganate per every liter of potassium permanganate, which tells me that the volume of potassium permanganate I need is 0.02 liters of potassium permanganate. Okay, final problem. And also, if I wanted to, I could put this back to milliliters, which would be 20 milliliters. Final problem, so looking at number 4, it says a redox titration required 12.5 milliliters of 0.08 molar potassium chromate, or dichromate, was used in an acidic solution to oxidize tin ions. So what we have down below is the balanced equation for this. So the first thing I want to know is how many moles of dichromate I had. So I'm going to take my volume of dichromate times its molarity, which was 0.0800. So for every 1 liter, there's 0.0800 moles of dichromate, which means that the solution contained 0.001 moles of dichromate. So then, now that I know how many moles of dichromate I have, I'm going to use my mole ratio to figure out how many moles of tin that would be. So for every 1 mole of dichromate, I get 3 moles of tin. Once I do that, I know how many moles of tin I have. So 0.001 times 3 is equal to 0.003 moles of tin. Now that I have that, it's asking for the concentration. So remember that concentration is moles over liters. So I have 0.003 moles of tin in 10 milliliters, which is the same thing as 0.010 liters. I divide that, and I know that the concentration of my tin solution is 0.3 molar. So hopefully these examples give you a good start on how to do these practice problems. If you have any questions, please make sure that you see me during office hours. Thanks.